Oh, this one's a bit more. Let's have a look at this one. Would that be a transit? It's got like this little that goes down and up and down and up, sort of variability trend. But that's due to the variability rather than the natural object transiting. So, oh, I don't know for this. To me, at least, there's nothing that's really outstanding. It may look like transits, but it's not concrete again. So no, I'm done with that one. Um, yeah, again, nothing. Oh, we got a more variable curve. Oh, this is a massive star. It's a really big star, this one. It's, uh, orange supergiant, at least. Where's my massive star collection? Oh, I think it must be if I click done. Just for curiosity, let's go and see what this star is. So just add it to my colossal star collection. There it is. And let's go. There's lots of nearby stars near it, as you can see here. HIP, oh no, HD 68763. Yeah, it's a red giant. Well, not a super giant, but as I mentioned before, but it's still massive. So yeah, I was almost correct in my assumption. So just mark it as. There we go. Let's go back. Ooh, hmm. So look at the subject info. Ah, it's another giant. But normally that would be enough for me to, because we had tons of noisy curves, that would be enough for me to mark it and mention it here. But no, this is probably due to a smaller binary star rather than a planet. I'm not sure what this W-shaped thing is. Probably due to the background flux or something. Maybe, I'm not sure. Yeah, because often people get confused when they look at this. They think this could be is a transit, and and then they think that this must be a planet because it just looks like it, but they often don't factor in the size. So I'm gonna so yeah, I'm gonna do that. So transit at day. Oh, I didn't record the size of it, but so because I didn't see the date properly, I'll just say roughly day 24 is not due to is not planetary in nature due to the size of the star. There we go. Just for curiosity again, just want to see what it is. It's a lesser known star. It hasn't got a HD designation, so CD 274307. It's an M types. That's that's not M type, I'm afraid. At least from looking at that temperature, it's hotter than an M type. Definitely. Sometimes I get this wrong, so something to bear in mind. Right. Let's look into this curve. It's part of the variability, that bit here. It's a systematic effect. Yeah, nothing really. So I've got another sort of pulsating curve-ish. Again, nothing, so let's go on. Again, the same sort of... It's really weird because you sort of get the same sort of type of star, several times in a row. And yeah, again, nothing. Another one. Another pulsator. Well, yeah, this is... I think this might be a Gamma Doridus? Or is it a Delta? Because how rapid the pulsations are, it might be Delta Scuti, I think. Because Delta Scutis and Gamma Doridus variables are quite similar. It's just that the usual difference is the pulsation period. Rapid usually means Delta Scuti-ish, or Delta Scuti type, and slower sort of ones are Gamma Doridus. So yeah, Delta Scuti. Anything more on the star? It's got HT designation. Yeah, there's nothing that's... We haven't found anything that looks planetary yet. It does take... Sometimes it does take a while before you do find one, but... yeah, so at the very start of the curve, it has like a systematic effect, which is like... So it starts down all the way down here for some reason. And then it sort of just squishes the curve upwards. I'm interested in this one here, probably this one here, so let's zoom in now into them. Because there's not many measurements up here, really. I'm going to mark this one. It looks really, really small. Okay, and yeah, this one's definitely not a transit. Okay. Yeah, again, not confident on this one, so I'm not going to mention it. Oh, we've got lots of transits here. We got a relatively big star, but it's not ridiculous for it to be planetary. But are they alternating? Let's have a look. Doesn't look like it. Maybe. It's in some cases it is, but in some cases it's not. There's an occasion here where it doesn't appear at all, which is weird. Alright, so I'm going to mark all these. Interesting. Doesn't appear to be... Is that the variability there? Or is that the... No, the variability goes there, doesn't it? Yeah, I think no, I'm just going to leave that as that. As long as you get most of them on, doesn't really matter, because it will still count as correct. But this could be a planet, maybe. I doubt it, but it could be. Just going to do the radius calculation. Just hold on 1 minute. So 2.338 over 0.25, and you get 1.169. So yeah, definitely planetary. Could be. Has the potential to be. Just marking them all on. It's always advised to mark as much as possible, and yeah, here we go. We got the, apart from just derive, because it's very messy up here, just derive it. So possibly there, and then yeah, there. Yeah, and that's what you get. Let's just check the period, because I've actually done that. So it's around 0.6, 0.65-ish. Yeah, I think that is. Alright, so press done and talk. Don't think any, because right at the start of the new sector, don't think anyone's going to see it. It is 0.6 is really quick, so on that basis alone, I don't think it is a planet. But let's have a look. Contamination ratio is really high. Check exofop. Oh, exomass, alright. Oh, whoops. Yeah, no reports popped up on there, so do the next best thing, which is check for background flux. So I'll do this off screen. Alright, so here's the curve. I've been at 30 points per hour, and so let's just zoom into a part of the curve. Looks like it's a TCE generated for this one, for sector 34. So let's do Shift B and check the background flux. It looks okay actually. Like it doesn't abnormally. Just check a few more points. Maybe it rises slightly, I'm not sure. It kind of does though, doesn't it? The background flux sort of rises above these transit points ever so slightly, so you just have this like slight upward tick. Oh, something went really wrong with there for the background flux. Let's go to the other end of the curve. Hang on, if I zoom out. Yeah, this thing here is normal. Usually there's a systematic effect, and that sort of just jumps the background flux massively high, but actually it goes back to normal. And none of the points are affected by it. So let's have a look. What I want to do is increase it a bit. Back to thing around here. It's not convincing though. It rises slightly over the transits. Oh, it's more clear here. Sort of. Yeah, so this is a difficult one. It has the potential to be a planet, but I'm not confident on it, but I am gonna, yeah. So, okay, so I've just done all the details for it off screen. Just looking at all of the different details that we've already gone through. So the transits are roughly every zero point 0.6 days. Might be too short to be a planet. The background flux looks normal, but maybe slight rises above the transits. I wasn't sure on that. Um, there's a TCE generator sector 34, but it's yet to be published on ExoMast. There's no TOI. The transit depth is indicative of a body of roughly 1.2 Jupiter radii, and the star itself is a HD 70736, and it's been listed as an F-type star, which, if you look at the details, I can believe that. So to me, it's possibly it could be possible, unlikely given the period. It is really rapid, so we have to be really, really close to its star. So it might not be physically possible for a body that close to orbiting that close to a star this size. And I've just linked to people that might know more about this, and then so we can get their opinions on this subject, and then we can come to a reasonable possible conclusion for this object. So it's our first possible planet. And that was yeah, that was curve number 34. So interesting indeed. Looks like here we got an eclipsing binary. Just check the size of the. Oh, that's yeah, definitely eclipsing binary. Anything over 3 solar radii, you're starting to push it. 4, yeah, it's unlikely anything over 4 then to get a planetary body. So yep, secondary eclipses here. Marked them as such. There's one there. Yeah, that's the eclipsing binary. Eclipsing binary. Sinbad. Ooh, don't know what that was. And there we go. Because it's far too big to be a planet, that. Oh, why has it gone white? Oh, you dark view. Just check around here. I'll delete all these tabs up here. Because it will get very long very quickly. And just have a look at it was 19 point something for the second momentum dump. I think it's around 19.4, 19.3-ish. I think so, yeah. Oh, we got. No, that's plenty. But is it too long though? That's the question. No, I don't think it is too long. Point 0.6 days is around 14 hours, so or at least I think it is. It goes away 2.4, so it's hard to assume in my head. But I'm gonna mark that, I think. Do I mention it? Yeah, I think I should mention it. No, no, no. Because it's so close to the momentum dump, I'm a bit skeptical. I'm going to mention it. Yeah. So possible transit. Possible transit day 19.5, and then close to, and then but might not be related to it. And then let's check exopop. Oh, actually, if I go to Aladdin light, then target. All right, so you can see the object is sort of orangish. Yeah, it looks like a sort of almost sun-like. It's a K type, G type boundary sort of star. So yeah, I think that's just all you need really. There's nothing else to add. Now I just check some notification. Yeah, that's what I thought it was as well. So that was the possible planet we just looked at, and a quick reply from good old David Bundy suggests that it's a close eclipsing binary. So it's not directly transiting the thing, but the background flux rises suggests that it is one. So there we go for that one. So that's not a planet, fortunately. Right, so we are at curve 37. There's nothing on that one. Kind of a systematic effect at the start of the curve, which is annoying. This might be due to a momentum dump. This drop here. Just for yeah, it's too compact to see any difference really. No, no, nope. I think a red dwarf star here. No, this is a strange one. Check the details. It's a giant star. Even something as small as that could be like a binary star, given the size of these objects. So I'm going to mark this little guy up here. But yeah, because you're advised to mark binary stars anyway. So yeah. No, got some flares here. This is a flaring star. Yeah, most flaring stars are often red dwarfs. So there you go. There's no transits on that one. There's no transits on this one either. No, yeah, it's variable, but there's no transits really. No. So I'll go over here. Is it this one? It is this one, yeah. No, that's due to momentum dump, I think. 5.9 is momentum dump territory. So I'm not going to mark that. No. Nope. We got here. It's like some sort of pulsator, sort of. It just pulsates up and then just drips down a little bit with some various measurements. Then boom, up, boom, up. It's almost like an RR ray, but this is clearly not an RR ray. It's the brightness variations are not big enough. Alright, yeah, let's get rid of that. This one's a red dwarf. Clearly variable. Oh, what's this? That looks like a transit to me. Given the small size, that is definitely planetary potential. So that's 10.4. Is there any more? .4 could be here. Let's go to the other end. Yes, there's another one, 23.2. That's a 13-day difference, roughly. So 23.2 and 10.4. Let's hope it's not a simulation. Oh, it is a simulation. Oh, two more. Oh, they were. Oh. So that one up there was possible. No. Oh, well. Oh, well. That's good. Brings us back to a new one. So we're up past the halfway mark now. This is kind of 52. That's one that, even though it's very close to the systematic effect in the middle, it's definitely one there. Are they evenly split? Because if they're evenly split, then this could be a bit an eclipsing binary. I think it is. Oh, someone's already done it. Apparently this is a TOY 2A983, and it's a false positive, and it's contamination from an eclipsing binary. Yeah. Yeah. All right. Interesting. Let's have a look. these are often the hardest ones to tell if there's chances or not, like slightly variable curves, because it's really hard to tell if it's just if it is due to if it's abnormal or not due to the well just the variability of the curve. So this one here might be promising. 24.4. This one here might be promising. 11.2. Check the size of the star. Yeah, F-type star territory. Maybe day 4, I suppose. Is there a pattern? Not really. There could be more of a pattern. Well, those are the easily identifiable ones. This little mess here might be something, but it's hard. Small transits, day 4. And 24.4. That's all I can really say, really. I don't think there's anything concrete. 37. So HD 373. 374. I had a mind blank there. 37573. Copy. Paste. And there we go.